Let me just take a moment. I want to go quick review because we have the time. All right, so be careful. Remember, we started all this thing talking about area, and we're soon going to translate into volume. That's where we're heading. So you can't confuse the two. What is area? Number of square units to cover a shape completely. And as we said, whenever you're writing area, you should write it in square units, right? Always in square units, always in square units. We start off with a parallelogram. Remember, the key is using the correct side for the base and the correct side for the height. And the height is always the perpendicular distance between those two bases. We went from there and did some parallelograms, looked at different situations with the height. We then talked about a rectangle. Could either use base times height or length times width, either way. Because it's all right angles, any side could be the height of a rectangle. We then looked at a square, said you can also use base times height. Again, because the sides are right angles, because all the sides are the same, you can just do sides squared. Again, though, you're going to end up with square units. We also looked at how to solve for a side. And then we got into a problem like these two. And you guys need to refer back to these as they try to give you insight in how to do further problems. The top one, okay, that's an odd shape. You don't have a formula for that shape. But you can break it up into shapes you do know. So we split it up into two rectangles and did area of total area is area of rectangle 1 plus area of rectangle 2. In the bottom shape, we wanted the shade portion, and there's like a bite taken out of it. There's a square taken out of it, which is a hole in the parallelogram. So to get the area that's shaded, you do the area of a parallelogram minus the area of that square that's a hole in it. And that principle comes up, right, time and time and time and time again. Got into triangles. I noticed just a couple of you, maybe just only one of you, you were missing that half on that formula for a triangle, and you can't miss that half. And remember, I told you that a triangle is half of the same size parallelogram. Base would be the same value as the parallelogram. Height would be the same value as the parallelogram. So the way you get the area of just the triangle would be half of that base times that height. But you can't forget the half. You can't forget the half because you're in trouble if you forget that half. Again, we talked about using the correct side as the base in respect to whatever height they give you. And it matters which height they give you. That will determine then what the base is, because the height is always perpendicular to the base. If you can do that, then you can handle problems like that. We went through a few of those. Did one with the base all the way out to the left. Got into a trapezoid. Half base 1 plus base 2 times the height. How do we know what are the bases of a trapezoid? Somebody tell me, how do you know which sides are the bases of a trapezoid? Alexandra? The parallel sides are always the bases of the trapezoid. And the height always has to be that perpendicular distance between those bases. You see a pattern, right? I mean, things are orderly in math. That height is always a perpendicular distance. Went through, did a few problems. This bottom problem here. So you got to look at this and say, hey, wait a minute. That's a big trapezoid minus the area of the whole of a triangle. Right? And using that procedure, we could figure out the area of that odd-looking shape. Went from there and got in circles. Area of a circle, pi r squared. And so, really easy for circles. All you need is the radius. However, remember, sometimes they'll give you the diameter. Well, that's okay. Radius is always half of that. Now you can figure out the area. Or sometimes they'll give you the circumference. Well, if they give you the circumference, first you got to use the circumference formula to get the radius. Now that you have the radius, you can figure out the area, and away you go. And we did some pizza problems. Remember, you get 25% more when you go from a 16-inch to an 18-inch. You get 25% more pizza for just 2 inches. It's worth it. Go for the large. And then an odd shape like that, what was that? That was area of a triangle plus area of half of a circle. Hey, we could have cut a hole in it if we wanted to, right? I mean, if we wanted, we could add a hole in the middle of it or something. And then you just subtract out the hole. Not a problem. All right, that brought us to our quiz then. And I gave you the formulas in a matching form. That was the nicest way I could do that, right? On the first quiz. I didn't make you remember them all. I gave it to you in matching form. But you do need to know your formulas. They're the key to everything. And so be careful. Make sure that you're reviewing your formulas. All right, we went over the quiz. And so now we are at 13.4. You do not need to take notes. You need to watch. All right? So as you know, you have no notes. And that's fine. That was my intent on 13.4. 13.4, 13.5, 13.6 are, in my looking at things, auxiliary lessons. If I have time, I get to them. If I don't, I don't. We have a little bit of time so we can explore them. They're decent lessons, but it takes some understanding to get to know them. All right, so you should be open to page 557, right? And I'm going to go, I'm actually going to change programs here because I can work a whole lot better in this program if Smart Ink doesn't mess me up. Tell me Smart Ink's going to be a smart aleck. Smart Ink may be a smart aleck. Get rid of it. Alright. Hopefully Smart Ink won't drive me crazy. I really, 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 really hope. But I'm about to find out. Okay, so if you look at 13.4, it talks about similar polygons. We've already talked about similar polygons, that concept. And what we talked about with similar polygons was we said this. We said the angles were congruent, and we said that the sides were, somebody raise your hand and tell me what the sides were for similar polygons. Raquel? No. Proportional. Proportional. So for similar polygons, the sides, the angles are congruent, but the sides are proportional. This is going to drive me crazy. All right, I'm already back. How can I do this? Let's get rid of that. That I need. Right, hold on. Technical difficulties. Try to work within a program and a program. Right, that is selected, so that should be good. This program is so much easier to use. Looks like I'm going to be stuck over at my desk here. That's okay. All right. I'll try to do this. I'll try to do this. I got to try to get on the microphone. Oh, well, whatever. Let's see how it turns out. All right, try to enunciate. Okay, so here's what we've got. Let's assume that this yellow triangle right here, let's assume that this yellow triangle right here, this one right here, right? See it? Right here? This one. Okay, let's assume that this yellow triangle is the pre-image, the original. I have a similar triangle right there in purple, right? The image. And I made this triangle exactly half the size. All right, got it? So we've got something that's about half the size. So let me go through, and this is going to be hard because I got to write numbers. And I don't have my pen. I'm writing with the mouse. Oh, get out of there. Okay, beautiful. Let's go. And oh, that's so ugly. That ugly number. Man. All right, so if that were 10, this would be 5 if it's half the size, right? Laughing at me. All right. So, and I don't know, I'm just going to make up a number. Let's suppose this was 22. Then down here on this bottom side would be what? 11. All right, good. You got it. And I'm not going to fool with the other side. Okay. The sides are proportional. The angles are congruent. The purple is half the size of the yellow. Right? Purple is half the size of the yellow. All right. I'm just going to make up a make-believe number here. I know this value. I'm going to stick an altitude in, right, which is a height. And I don't know. Let's call that, just for fun, 8. Okay. Let's figure out the area of the yellow triangle. You can write it in your book. You could write it on a piece of scratch paper. You could do it in your head. I want you all to figure out the area of the yellow triangle. What is the area of the yellow triangle? Okay. Again, I know those numbers aren't the biggest. I got to make my, actually, if I make my pen fatter. Let's go to it's a little better. Okay. All right, somebody raise your hand. You've got an area for me, Nick. 88. How many agree with Nick? 88 square units. All right. So Nick did 1/2 base 22 times height 8, right? 1/2 base 22 times height 8. It's not as easy to go back on this program, but that's life. All right. So that he just said 88 units squared, right? Okay. So remember, this purple triangle is, each side is half the size of its corresponding side. Agreed? Agreed. So don't say anything out loud, what do you think is the area of the purple triangle? Don't say anything out loud. Okay. So the yellow triangle's area was 88 units squared. What's going to be the area of the purple triangle? If you've got an idea on 3, I want you to say it out loud, okay? If you don't want to say anything, you don't have to. If you've got an idea on 3, say it out loud. Here we go. Ready? 1, 2, 3. 22. Okay, I heard 22. I heard 24. Did I hear 44? Right. How many 44s? That's the natural answer, right? 44, everything's half, right? The side that's 10 is half on the purple 5. The side that's 22 is half on the purple 11. And the other side we didn't name is half. Well, let's take a look at the triangle. See, I can move it, which is nice. Let me stick it down here. Now you can see that's halfway across the bottom, right? Here, I'll do another one. You see how that gets me all the way, right? And I can do the same thing the other way. Does that look like half of the yellow area? Because look, here, there's a second one already right there, right? And look, I can stick a third one in there, right? And I wonder if I duplicate this, I wonder if I flip it. Let's see, I gotta flip this thing vertically, which I believe is that. Oh, now I gotta flip it the other way, which I believe is that. Is that gonna fit in there, you think? Yes. Whoa, look at that. So, now you can figure it out, right? And so, what is the area? 22 square units. What? How did that happen? What in the world just took place that was 22 units. All right, listen to this. This is the key to what we're doing here in lesson 13.4. The sides are proportional. The areas are proportional, but in a little bit different way. The areas are proportional to the sides squared. The areas are proportional to sides squared. So let's see if I can make this make sense to you guys. All right, let me move my 5 and my 11, put them back. Whoa, catch them. Put them back where they belong. Over here, I'm all purple and hot. Okay, so let me go up here. I'm going to make a proportion. See my desktop. All right, so let me go up here. I'm going to make a proportion. All right, beautiful proportion, isn't it? What happens when you got to write with a mouse? All right, so I want the area of the purple. Put that in the thing. Let's get rid of that. Divided by the area. Come on, draw of the yellow. I want the side of the purple over the corresponding side of the yellow. But here's the key. The areas are proportional to the sides squared. The sides squared. All right, it's an ugly looking formula. That's what now you're thankful I write with a stylus instead of with a mouse, right? So let's go through and let's stick in the numbers. You don't need to write this, just watch. So we're figuring out the area. Come on, let me draw the next line. Stupid thing. All right, I'll get your somehow. There you go. All right, whatever. All right, our area of our purple was 88 square units. Agreed? Okay, 88 units squared. It's so hard to write with this mouse. Get rid of this. Okay, and we have purple on the top and yellow on the bottom. Yes? All right. So let's choose the side 5 for the purple. And we got to square it, right? Proportional side squared. If I use the 5 from the purple, what do we got to use for the yellow on the bottom? 10, right? So 10 squared. All right, so my area is going to equal 5 squared is 25. And we're going to multiply both sides by 88, right, over 1. So I get 88, right? And 10 squared is? All right. Let's go reduce. What happens if you get a 25 on the top and a 100 on the bottom? You get a 4 where? Top or bottom? Didn't we get 4 triangles to cover that yellow triangle? Right? Don't you remember? It took 4 of them. Here, I'll do it again. All right, here we go. There's 1. There's 2. There's 3. Now I got to transform the other one. All right, range, transform. By the way, transformations, right? Let's just rotate it. It's probably easier. 180. And in it goes, and 4 of them, right? And doesn't the formula, in this case, tell us 4? And so 88 divided by 4 is 22 square units. Voila. Isn't that beautiful? So the areas are proportional to the sides squared. The areas are proportional to the sides squared. That's the way it is, and that's something that you need to remember if you were to use that formula. All right, let me go through and let's look at another relationship. Oh, I got numbers everywhere now. Take the purple guy, I'm going to move him back over here. 5. Oh, stay. Oh, go. Okay. You agree we know the altitude of the yellow triangle, right? So what's the altitude of the yellow triangle? Height, I'm sorry. Height. 8. By the way, height and altitude for a triangle are the same thing. They mean the same thing. All right, the height of the yellow triangle is 8. How can we find the height of the purple triangle? Anybody have any idea how to find the height of the purple triangle? Adriana? Are you sure? Are you sure the height is proportional as well? We learned, right, that the angles of one polygon are congruent to the angles of another polygon, and we learned that the sides are proportional, but is H a side? It's not a side, is it? It's the height. It's the perpendicular distance between a base and the opposite vertex. So it's not a side. So is it proportional is the question. Are heights or altitudes proportional? Let's do it this way. All right, so tell me out loud, what was the area of our purple triangle that we found? 22 units squared. Let's use the formula area equals, oh, now I'm really in trouble. Boy, I got to do something else for tomorrow. 1/2 base times height. Area of a triangle. Agreed? All right, let's substitute in. I'm not going to use my units because it's hard enough to write as it is. 22 1/2. What's the base of our purple? Our purple. 11, right, times H. Okay. 22 equals 11 over 2 times H. Let me put it a little higher for you. All right. If you were solving that equation for H, somebody raise your hand and tell me what you'd do to solve it for H, to finish it off. What would you do to solve it, to finish it off? Come on, participate. Sam? Tell me what to multiply both sides by. Right? I would multiply both sides by 2 over 11 on that side, 2 over 11 on this side. Our 2's would divide out. Our 11's would divide out. Hey, we isolated the variable. What's 22 divided by 11? What's 22 divided by 11? And 2 times 2 is? What's our height? Our height is 4. Just picked up my 4. Let me see if I can write a real 4 here. 4. Now, what do you think about the heights? They are proportional. But now we know it for sure. Well, did all kinds of stuff. Now we know it for sure because we figured it out using the formula. We know the area. We use the formula to figure out the height. And lo and behold, indeed, they are proportional. I'll give you one other term here for geometry later on when you get it. Triangles also have another type of a line. Let me see if I can. No, I don't want to do that. All right. They have another type of a line. This is called a height or an altitude. There's also a thing called a median. A median goes from an opposite vertex to the midpoint of the line. Is a median. So in other words, here to here would be 11, and here to here would be 11 on both sides of that point right there. It's called a median. Every triangle has 3 medians, by the way. You could go this way, right, to the middle. That would be a median. You can go this way to the middle. That would be a median. What do you think about the medians between 2 similar polygons? What would you guess? They are also proportional. All of these relationships take place within similar figures. So lesson 13.4 is really about getting you guys to understand the heights are proportional. But remember, key, the areas are proportional to the sides squared, right? The area is proportional to the sides squared. I could have done the same thing down here with these parallelograms. So You can see this parallelogram is half the size of the purple. And what's the area? Because it's a half, it's going to be 1/4. That's only because it's a half. Right? Same thing, but only because it's a half. Because what's 2 squared? 4. What if I made this thing a third? See if that's about a third. That's pretty good. It's about a third, right? If it's a third, what do you think it's going to end up being? 2 squared is 4, and the other one was 1/4. This one is going to be 1. It's a third. 1/9. What's 1/3 squared? 1/9. Because look, there's 3 of them. There's 6 of them. And there's 9 of them, right? 1/9. Hey, what if I made this thing 1/4 the size? I don't know how close I am there because I'm just guesstimating. Yeah, it's close. Close enough for government work. Not that close. A little bit tinier. Here, let's go this way. They're so cute. Hey, there we go. That's close enough. Fill it up. So what if I went 1/4? 1/16, right? 1/4 squared. There's 4 more of them, and 4 more of them, and 4 more of them, right? It's 1/16 the area. Get the relationship? It's the area is 1/2 is equal to the proportion of the sides squared. All right, that is. My voice is killing me already because I'm trying to enunciate. Cole, can you hear me? Hopefully you can hear us. All right. Turn to 13.5. 13.5. It's a horse of a different color. Those numbers are left over. Zoom in more. All right, so this shape is called I think we dealt with this, right? Prism, right? So we've done prisms before, and this is a prism. But now we're going to do volume Monday next week. Right now we're still looking at area. I should have brought in a box here. Yeah, I know. I can just get rid of all the tissues. All right. Cole's definitely not going to be able to see this, but sorry, Cole. I'm taking a box of Kleenex tissues, and I am murdering it, yes. Slicing and dicing. Okay, quiet please. Would you guys agree this box is a prism? Right? And it's similar to what you see on the screen. Alright, I have just cut up the top. Look, the surface area, here's what the surface area means. Okay, I need all of the area of this front face of the box facing you, this bottom yellow portion, this top yellow, the back, the white back part here, this white part here, and this white part here. And they're all rectangles. So it's really the area of the bottom rectangle, the top rectangle, the right rectangle, the left rectangle, the front rectangle, and the back rectangle. That's the surface area of the shape. Right? So now I've cut the top open, so I need, right, surface area of the top. I've got to keep cutting. Let's cut this here. Now I just cut out a side, right? I need that surface area, right? I'll cut out another side. All right, there's the surface area of that side. And then here's the surface area of the bottom, right? And then here's the surface area of the back. And we'd have to figure out the surface area of those shapes. But that's doable because usually you're going to give you a few numbers. Let's see now my terrible writing here. I gotta magnify a little bit here. Smart people, right? Going at it. Such a smart aleck. Okay, so let's just make up numbers. I'm just gonna make up numbers. Let's suppose this bottom number is 20. Therefore, this top number across the top right here would be what? 20. So if that's 20, we know that's 20. Let's call this 8. Okay. Let's call this 12. And with just those numbers, we could figure out the whole shape. Because how much would it be across here? 8. So if we call this area 1, we would go base times height, right? Oops. We would go base times height. What would be the base? Say it if you know it. 20. What would be the height? Say it if you know it. 8. 8. Yellow. Look at the yellow top right here. Right? You got to look at the yellow top. The base is 20 right there. And the height is right here, the 8. Okay, it doesn't look perpendicular, but remember when you draw something in 3D, you angle it to make it look proper. So 20 times 8 is the yellow area. What would be the bottom area? 20 times 8. What would be this right-hand side area? How would you get it? What times what? 8 times 12. What about this side? 8 times 12. There's 2 of those. So there's 2 tops. There's a left and a right that are the same. And then there's a front and a back. What's the area of the front? 20 times 12. What's the area of the back?
20 times 12.
We just figured out the surface area of that prism. All right, we just did the surface area of that whole prism in just that one fell swoop there. It's that easy. That's simple. Where are you supposed to have your book? Open the what? That's what it needs to be open to. Anybody in the front volunteer to be a person in the back? Anybody want to go to the back? Let's see, you only came up front for what? No, did I put you up front for? I put you up front for a reason, didn't I? Gabe, you want to go in the back?
Yes.
You think you'd be okay back there?
Yes.
I'm not so sure. Anybody else want to go to the back? Austin, you want to go back? Okay. Austin wants you in college swap. Couldn't do it now. Rest of the year. Okay, so surface area. Jordan, question?
Yes. For the box, after you do all the base times height, you add the top.
Yeah, you're adding it up because you got to get the whole surface area. You got to end up with all the area of all the rectangles. Right? Top area, bottom area, left side, right side, front, back. Can any of you guys pay attention? Is that possible? Are you guys that bad? Because here I am looking at you, and most of you aren't paying attention. And that's your issues, and that's why you don't learn stuff. Because you don't pay attention all the time. Believe it or not, this shape and the other shape are exactly the same. I just made the sides green instead of Yellow. Would it matter if the prism was sitting that way instead of the other way? Is the surface area going to change if it's the exact same size and shape? No. The numbers are in a little bit different spot. Now, instead of the top and bottom being the yellows, now the top and bottom is what used to be the sides. It's still going to have the exact same surface area, right? If I took the Kleenex box and I did it this way, is it any different than the surface area when it was that way? No, because all of the sides are still the exact same size. And when you do surface area, you've got to take that shape, split it apart, and figure out then all the surfaces, or the area of each surface. So it becomes a bunch of problems. Here's a prism. So, what would this thing look like when you split it apart? Well, you got to figure out the area of this bottom base. Here, let me circle this up. You got to figure out the green area of that triangle on the bottom. By the way, thankfully, it's exactly the same as this one. So you can do it once and multiply it by 2, right? Now, sometimes a prism, it depends upon the shape, whether or not all the 3 sides are the same. You have a side here. Let's see, I got to get back to my pen. You got a side here, you got a side here, and then you got the back that's hard to see. That's like right there. So you have 3 different sides, and you're going to have to figure out the area of each of those 3 sides if you're going to get the total area of that prism. Get rid of that. Here below, the exact same prism sitting the other way. And hopefully, again, you can clearly see 2 triangles. They're the same size, but because if it's angled, one looks bigger than the other, but they're the same size. 1/2 base times height, and then you have 3 what we call lateral surfaces. That's the rectangle on the bottom, the right-hand side rectangle, and the left-hand side rectangle. You'd have to figure out the area of the 3 rectangles plus the area of the 2 bases. Voila, you would have the total area of that. So look on page 583? 563. You can see they kind of did what I did on the top with the tissue box. They show the shape split open. And they split it open a little bit different way than I did. But again, you can see, the back is still the back. The top is flipped up. The bottom is flipped down. One of the sides is flipped left, the other side is flipped right, and then the front is flipped to the right there. And again, you're just figuring up all the surfaces. Surface area, it's not bad. It's like 4 problems in one, 6 problems in one, 5 problems in one, depending upon how many lateral surfaces you have. So 2 things today. Similar figures, sides, heights, medians, are proportional, but area is proportional to all of those squared. Area is proportional to the sides squared. Area is proportional to the heights squared. And then surface area, how do you figure it out? You have to figure out the area of every shape that is the surface of that figure. Do that, and you'll have the surface area. All right, that's it for today. No homework. You'll enjoy that.